Okay, we are starting chapter 1, and if we're in class, we actually did sections 1.1 and 1.2 together. I'm actually going to make 2 videos of this, one of just section 1.1, and then the next video will be section 1.2, okay? So, start off, we're going to go into section 1.1, which deals with expressions and variables. Now, what I talked about in class was I wanted you to be able to understand some of the language that we're going to be using during the course of the year. And many of the definitions that I'm going to put in the notes are really important because there's going to be a time where I'm going to use those terms in a math lesson or in some kind of instructions such as questions and whatnot. And I wanted you to know what those definitions meant so we could properly use those meanings in any form of mathematics. So, first one we have right on the board is numerical expression. Numerical expression, the definition is a math expression consisting of numbers and operations. Well, operations is either, multiplying, dividing, adding, and subtracting. And then numbers we know. So an example of a numerical expression would be like, say, 2 plus 3. We have numbers, which is 2 and 3, and then we have the operation, which in this case is addition. Another thing to keep in mind about the word expression is, in more simplistic terms, it's a math problem without an equal sign. Okay? The next definition we're going into is variable. Variable is a letter used to represent one or more numbers. Now, I talked about in class that normally the letter that we use, the more common one is we use is either X or Y. It certainly can be other ones, but most common practice, or if there is no variable used, most of the time we'll either use X or Y. And it says it's going to represent one or more numbers. I would say probably for the early stages of this class, it's just going to represent just one number. And then the next one that we have here is variable expression. So we're going to take both of the definitions up top and kind of combine them. So it's going to be a math expression, which we talked about was a math problem without an equal sign, which consists of numbers, like the 2 and 3 we had up top, an operation like multiplication, division, addition, or subtraction, and a variable, so it would have an X or a Y. So keep those in mind when we start talking about different concepts and different things that it's going to help us throughout our math careers. One thing that we have up there, I posted a question of when does an expression become an equation? So we've established that we say no to the equal sign for an expression. No equal sign. An equation is a math problem with an equal sign. So we can say yes to equal sign. So anytime you say, okay, let's solve the expression, okay, we're just doing a math problem without an equal sign. If I say, hey, let's solve the equation, then we're going to say, yes, it includes an equal sign. Okay? Next thing we're going to talk about is evaluate. Evaluate means solve a numerical or variable expression. So when it says in the directions evaluate this or something like that, that means we're just going to solve the problem. And we're going to dive into a little bit in section 1 about what is called the verbal model. The verbal model is a description It describes an expression or an equation using words and math symbols to relate those words. So you use those words in math every day. You just don't always see it. So let's put up verbal model here. This is what's going to help us figure out what we're going to look at. And there's some key words that I want you to see that it's going to be like, oh yeah, that is going to be an addition, subtraction, multiplication, or division. Being able to find those words in a sentence, you will be able to solve the problem much easier and have more success. So if we look at addition, some of the key words that you would see in a sentence would be like plus. Another one would be the sum of. Another one would be increased by. And another one would be, let's say, the total more than added to, or like total. Maybe just total would be. Let's do this. Let's say that just total is it's itself. Sorry about that. And then let's say more than added to, more than. And then let's say added to. So let's say here, 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 and here. Okay? Those ones would be keywords and define what we're looking for. Another one would be, say, for subtraction would be like minus. Next one would say would be like difference of. Since it was increased by, we can say it's decreased by. Fewer than. Less than. And subtracted by. Those ones would say, hey, this is a subtraction problem out of words. For multiplication, we could say times. Something times something. The product of. Multiplied by. And then for division, we can say divided by. Divided into. And the quotient of. Okay, so those things are going to kind of help us out, in which we're going to do right now. These are some words, phrases that are going to help us figure out which kind of problem we're going to write out. So we're going to write out the problem using the words in each sentence. So the first one is the product of 72 and a number. Okay, when you see product, if you go back to the model, that was one of them. Let's say, all right, that's going to be a multiplication problem. All right, anytime you see the word a number, that is code for variable. Okay, and so once I see variable, okay, I'm like, all right, so that means I'm either going to use, say, x or y, and I know it's the product of, so we're going to multiply this, so I can say that this is 72 multiplied by x, or you could also just write it as 72x. No problem there. Next one, the difference of a number and one. Difference is going to be subtraction. A number tells me it's we got a variable, so I got, say, x. Difference is subtraction. I'm going to go minus 1. Going down the list, I got a number divided by 41. So I got that number. So a number is a variable, x divided by 41. You could also write it as x divided by 41 as well. Both of those are acceptable answers. Last one on this page is I have the product of 3 and the number is 30. There's a little bit different now. So here I have product, so that means multiply. I have 3 and a number, so I'm going to do the product of 3 and a number. So that's going to be 3 times x. The word is right here. Is code for equal sign. So in this statement, we are actually finding an equation. So the product of 3 and a number, 3 times x, is, so that means equals 30. Okay? From here, we're going to evaluate the expression when y equals 6. So what we talked about, what was evaluate mean? Evaluate means solve. So we're going to solve the expression. So in order to do that, we have questions 1 through 4 presented in front of us. And what we're going to do is this. The step 1 is we're going to replace y with 6. And we're going to do that for all 4 problems. So let's just do that to all 4 problems. So now I got 24 divided by 6. I got 5 multiplied by 6. I got 20 minus 6. And I got 19 plus 6. So now from here, I can just solve using the operation that's given to us. You know, number 1, the operation is division. Number 2 is multiplication. 3 is subtraction. And 4 is addition. So for number 1, 24 divided by 6 gives me 4. For number 2, 5 times 6 gives me 30. And for number 3, 20 minus 6 gives me 14. And 19 plus 6 gives me 25. So that's how we solve those. This one has a little bit more of a wrinkle to it because they give you more than one variable. So from here, they give you m as in man equals 7, n as in nail equals 9, and q equals 10. So I'm just going to replace the number with that specific variable. So like for number 9, even though it says n times q, that really means it's going to be 9 times 10. For number 10, it's going to be 18 divided by 9. For 11, it's going to be 7 plus 10. And then for 12, it's going to be 29 minus 7. And then I just solve the operation. So now I got 90 for number 9. I got 2 for number 10. I got 17 for 11. And then I got 22 for 12. Last thing I have here for section 1.1 is kind of just an additional practice from what we had on the previous page. So from here I have a number, which is a variable, added to 27. So a variable added to, so that's addition 27. These are all expressions, so that means that they do not have an equal sign. 20 is where it's a little bit of the wrinkle. It says 6 fewer than a number. Now, a lot of people think, okay, I got the 6 first, and fewer means subtraction, so I need to write it like this. And that is incorrect, okay? The reason for that is the example I used in class, so let's say you had a basket of oranges. And let's say, for instance, that number is how many oranges do you have in the basket? Say it's 12. So say we wrote it then 6 fewer than 12 oranges. Something to that extent. You know. So if you were to write it like this, you would have written it as 6 minus 12, which would have gave you a negative number. So we know that's not true. So that means that the only way that this can be written is put the variable in front, minus it by 6. That's is the correct way. So a lot of times when you're doing taking words and put it into a math problem, you have to make sure that it makes sense. Now, for addition and multiplication, it does not matter how you position it. The only time it does make a difference is between subtraction and division. So keep that in mind when you're looking at these problems. Last two I have is the product of a number and 7. So you can write it like this, even though the variable's in front, you can have it like this. But more standard practice is to put the variable behind the number. This one's more accepted, and as we get further into math, I would like to see this more than this one. So keep that in mind. And then the last one is going to be the quotient of 56 in a number. So right here we know that this is division, so I got 56, and we're going to divide it by a number, which we'll call it x. And that is section 1.1, dealing with expressions and variables. Hope this helps. Until next time.